right, so chemistry. These are the solutions for the day 49 particulate diagram assignment. Let's go ahead and get started. There's 6 problems. I'll give you 6 chemical equations. I'll do 4 of them. You do the other 2 on your own. Okay? All right, so let's get started. Well, the first one is the one that you saw in the sample video. So see if you can do that on your own, in the lecture video, I should say. So go ahead and see if you can do that on your own without looking back at that. But if you need to look back at that, you can go ahead and do that. I'm just going to divide it into 3 sections. And although I didn't label it like this on the lecture video, this is the beginning. Or let's call it what they are. These are the reactants. Anything on the left side is called reactants. These are the intermediates. Now, chemical equations don't always happen in one intermediate step. And that is a unit of study that we get into in advanced placement chemistry, or that you get into in college chemistry. We don't need to deal with it here. We're just going to assume that there's really 3 steps to this. There's the reactants, they break apart into intermediates, and they end up as products, okay? So that's really one step, from here to here, and then here to here. But we're going to just assume that for the sake. So we have one CH4. It doesn't matter what the geometry or the actual shape of this molecule is. You can just make one up. This is actually a pretty accurate diagram. Kind of a symmetrical molecule with a carbon in the middle and 4 hydrogens around the outside. And oxygen is going to be 2 oxygen atoms bonded together. That's O2. And this says that you have 2 of them. So that's what you start with. And somehow these molecules smash together. And what happens is this is burning methane gas, the kind of gas that you get in the lab that we use in the Bunsen burners. Unfortunately, we didn't get a chance to use that. We would have done those in the second half of the class. But what happens is when you put enough energy in, these start moving around faster. High energy makes them move fast. They start smashing into each other. Exactly how that happens, we don't get into here. We just understand that it does. And what you end up with is a carbon. And then you're going to have 4 hydrogen. They've broken apart. That methane is broken apart. And then the 2 oxygen molecules have broken apart into oxygen atoms. And then what you can do if you want is you can just lightly draw some lines. They're going to recombine. You say, why do they get this and why don't they go back to that? And that again gets into other areas of chemistry that we're just going to accept that it happens at this point. So what will happen is you have a carbon come here and a couple of oxygens come here, and you end up with CO2, carbon dioxide. And again, this is pretty accurate. Carbon dioxide is a linear molecule. It's just a nice straight line like that. Now what about the others? Well, this oxygen can come over here. A couple of hydrogen could come up there as well, just like you saw in the lecture video. Oxygen is a little bit bigger than hydrogen. And then the other oxygen can come over here, and the other 2 hydrogens can do the same thing. And so what you end up with is 1 CO2 molecule and 2 H2O or water molecules. Okay? And that's a particulate diagram. It's just a way to get a visual of what that chemical reaction is telling you is going on. Okay? Let's go on to the next one. We'll again divide it up into 3 sections. Okay, so you have 4 aluminum atoms. These are individual atoms. These are pure elements. And then you have 3 O2 molecules. And what will happen is the aluminums are already separate. And the oxygens are going to separate into individual atoms. You have 6 of those. And now they're going to recombine to form 2 aluminum, what's called aluminum oxide. We'll get into naming conventions later on. It's aluminum oxide. And so they come over here. So you'll have 2 aluminum, and you'll have 3 oxygens. And how exactly those are shaped and connect, we're not really worried about that right now. We'll just draw the aluminum like this. And we'll draw oxygen like this. All we know is they're connected somehow. The actual structure is something we talk about later on in the class. So you have Al2O3, and it says we have 2 of those. And so that's what you would end up with. So that's what this chemical equation is telling you is happening in picture form. Okay, let's move on. N2 and H2 gives you NH3, which is ammonia. It's the same kind of ammonia you have in your house that you use for cleaner. So we have one N2. Again, that's just going to be a diatomic molecule. We talked about that a little while back, just like oxygen, O2 is diatomic. It needs 2 atoms to make a nitrogen molecule, and you have 3 hydrogen. Okay, they're going to break apart. Smash into each other. I mean, that's really what chemistry is about. It's about molecules smashing into each other and breaking apart and then reforming. Okay, and we have 6. So we have H2, we have 1, 2, 3, 4, 5, 6 hydrogen, and 1, 2, 3, 4, 5, 6. And now they're going to come back together. And so you're going to have a group here and a group there, right there, and so you end up with NH3, which is ammonia. Okay, and there you go. That a little bit more better on screen there, and there you see how that happened. Okay, that's all this is about. It's just visualizing in picture form what a chemical equation is telling you. I'm going to do one more, and then I'll leave the last 2 for you. Okay, and there should be an arrow right here. I'm going to draw a little tiny arrow. So why don't I go ahead and do this one since I left out the arrow and had to correct it. So there's an arrow right there. Okay, it's got a lot going on, but again, we're not worried about the real geometry or what these molecules look like. We're just kind of drawing a diagram that kind of approximates what they look like. So H3PO4, who knows, okay? I mean, you're saying at this point in your chemistry knowledge, you're saying, I don't know what that looks like. So, we're going to form an O here, an O here, there's 4 O's, an O here, and an O here. So later on, we'll worry about what these really look like. We'll put the 3 H's, because it says there's 3 H's, we'll just stick them on one of the oxygen molecules. Yeah, we don't really care. It says we only have one of those, thankfully, so we don't have to draw that a second time. Now we come over here to the middle. The phosphorus is going to be there by itself. It's going to break apart. The 4 oxygens are going to be there. And the 3 hydrogens are going to be there. Okay, and now, oh, and I forgot the 5 HCl's. Oh my gosh. Okay, so we got, HCl is just going to be H, and Cl, hydrogen chloride, hydrochloric acid. Let's just draw 5 of those. There's a lot of things to draw here. Glad I'm doing this one with you. That's probably the most complicated one. Okay, there's 5 HCl. Okay, now they go over to this, and you have P, and we have to draw all those here. Okay, so I have 5 more hydrogens to draw. Let me just do that here. These are not connected. Just drawing them close together. Okay, and I've got 5 Cl, so I'm going to draw those over here. The whole point is they're breaking apart. They're all breaking into individual atoms. Okay, that's everybody. It's a little crowded there, but that's everybody. So now we're going to put them back together into PCl5. So you have one PCl5. You only have that one phosphorus. So we're just going to draw that. And I'm just going to draw 5 circles around that. Each one is a chlorine. So there's PCl5. It says we have one of those, and then we have 4 H2Os. So you know what you can do is just X them out as you've used them. So we have those. And now we got H2O, so we need 1, 2, 3, 4 oxygens, and 1, 2, 3, 4, 5, 6, 7, 8 hydrogen. So okay, and there's 4 water molecules, H2O. So that's what you end up with. These smash together in some complicated fashion that we don't need to understand. They break into individual atoms, and then they recombine. Why do they recombine? What's a simple explanation? Why do they recombine to this instead of going back to that? And the answer has to do, it's a more stable, this is just the generic answer for why chemicals or atoms combine in certain ways. It's more energetically stable. They are in a more comfortable energy state. When you hold a pencil in the air and you drop it, it falls from a higher energy state to a lower energy state. And when you put the atoms together in this format, they generally go to a lower energy state. So it's like this is a higher energy state, this is a lower energy state. And not always. It's not always lower, but usually it is. And again, that gets into some more advanced concepts of chemistry. So it's just a simple way to think of why do they want to make this combination. Okay, so that takes care of this, and we'll see you in tomorrow's lesson.